So we're talking about text. Text or strings are just series of characters. Characters that can be generated from a keyboard or whatever. Each character has a numeric value. I mentioned that a couple of times. They have what's known as an ASCII value. So if we go to asciitable.com or you Google ASCII chart, you can see that a capital A has a 65 and a capital B has a 66 and so on. Well, one of the things you can do with text is to try to obscure it. How could you do that? Well, what if you took every letter in it and added one to it? So instead of the word bad, B-A-D, 66, 65, 68, it then said 67, 66, 69. So instead of seeing B-A-D on your screen, you saw C-B-E. Be hard to read, right? That's known as Caesar's cipher. So-called, back from the times of Julius Caesar or whatever, you had to have, some way of sending a message out to your generals or whatever, and so they would come up with a code where they shifted the letters up or down by a certain number. So, you could take that A and you could shift it all the way to a J, right? You'd have to add 65. Well, if you're going to a K, you'd have to add 20 to every value. Well, what happens when you hit Z? You might want to wrap it around, right? So Z and then carried on, 20 characters that way or whatever. So that's called Caesar's cipher. That's one form of encryption. It's a cipher. It's not a real strong form of encryption. It would take the NSA about 1 nanosecond to figure out a message that was encoded with Caesar's cipher. So let's go ahead and, well, here we go. It's easy to observe data that's crossing a network. Somebody could hook up a network sniffer to your network and capture all the packets going by it, and if the data is coming down as so-called plain text, then it's real easy for them to put together what you're doing. And plain text is just unciphered text. And that's why plain text passwords are a real problem. If people store passwords as plain text in a database and somebody else gets a hold of that database, boom, they already have all your passwords with no trouble, nothing obscured about them at all. So data encryption can be used to protect information. Many protocols have secure versions, like there's HTTP, but there's also HTTPS, which stands for secure. And the idea behind that is you get to see the data, and the server knows what the data is, but somebody who's watching the packets come from your machine or from the server can't see what the data is. One or more keys are used to encrypt the message, to produce ciphertext, and then to decrypt the ciphertext back to its original form. So Caesar's cipher is one of those. Block cipher is another. So Caesar's cipher replaces every character with a character a given distance away. So if you're adding 3 to each character, an I becomes an L, an N becomes a Q, a V becomes a Y, and so on. And then to decrypt, you got to shift the other way. And so they give us some code for doing that. It's kind of lame that they give us a code for doing that, because that's usually one of the projects I assign. On Thursday, I'll show y'all the list of projects that I suggest that you pick from. But then you can also come up with your own idea, and then they'll be due at the end of the semester. But we can play with this a little bit. ORD is the function that gets the numeric value of a character, the ASCII value of it, and in CHR is the variable, the function that turns it back into an ASCII character, into a letter. So if we have something like this, I hope I did start the recorder. Yay, alrighty. I'm just going to make a variable called ORC for original character is equal to A. Now I'm going to get the ASCII value of that. ASCII value of that A is equal to ORD ORC. Didn't really mean ORD and ORC to look so similar. How about just calling it OC as the regional is OC is equal to A, and then AV is equal to ordinal C. But let's put a comment as to what's going on here. an N, I believe. Alrighty. Now what I really need to do is, OC is a string. That probably will work, but what if OC was longer than one character? I'm going to run this and just make sure it doesn't crash. Didn't crash. What I'm kind of curious about, though, is you can't take an ASCII value of something that's more than one character long. So what if I typed in extra data? Would it give me an error? Yeah, okay. So it really only wants one character. All right, so if we print AV, the ASCII value, and OC, the original character, it's going to print that it's 65, because by that ASCII table, a 65 is a capital A. So what happens if we add 1 to the ASCII value and then convert it into a new character? Right, so AV plus equals 1, and a new C for new character equals this character value of that ASCII value. And then let's print those out now. Print the ASCII value, AV, and the new character, NC. There we go, 65, 66. So if we had the letters of a word in a string, excuse me, as a list, not as a string, but as a list, like this. Word equals, and I'm just going to put some characters in, quote, P, end quote, comma, quote, Y, end quote, comma, T, end quote, comma, quote, H, you can see where this is going, end quote, comma, O, end quote, comma, N, end quote, comma. I could get the ASCII value of every character in that list and make a new list of ASCII values. Well, to do that, I'm going to make an empty list. This is an empty list. I'm going to call it A values. It's a little bit too long. How about A val equals, and then if you do a list like that, a square braces with nothing between it, it means there's nothing in there yet. Right, if I print out aval, it's not going to show anything. So let's go through this list, pulling out each character line by line. So for V for value in the word, for V in word, colon, let's get the ASCII value of that specific character. AV is equal to ORD, the ordinal value of that specific place. Now this is using a for each list. Let's add 1 to it. AV plus equals 1. And now let's append that to our list. Aval.append, I think it's actually add, excuse me. I'm probably going to get this wrong and have to change that to .add rather than .append. Nope, got it right. All right. And once the list is done, let's print out the original word, print word, but then let's print out our new word. Wait, we don't have a new word yet. We just have a series of ASCII values. But that's okay. Let's print it out anyways, just to see what it looks like. Alrighty. That's quite not what I wanted to see at all. I have goofed. Oh, that was supposed to be my variable names are kind of bad today. That was supposed to be print a val for ASCII values. Now we're going to see the ASCII values of everything, but they're going to be shifted over by 1 because we've added 1 to them. Maybe I shouldn't have added 1 to them. Maybe I should have saved that for a later step. I think I'll do that. I think I'll delete that line, AV plus equals 1. And I'll just comment it out. So when it runs now, we will see that we have a list of everything that is in that prior list, but we have the ASCII values. And if we looked them up, a lowercase p is in fact a 112, and a lowercase y is a 121, and so on. You can kind of see this order because LMNO, N is 1 before, and O. That looks good. That looks right. We could have done this code right here, these 4 lines of code, in one step using something called list comprehension. I don't want to make things overly complicated, but since we do see that we're using a for loop to step through a list and to create a new list based on it, I want to show you the list comprehension way of doing the same thing. So eval2, I'm just making a similar version of the list. Eval2 is equal to, and since we're creating a list, I'm going to put square braces. Now here's where the syntax looks a little bit weird. It's okay. ORD V into parentheses for V in Word. I am going to go ahead and delete that line now. So if you haven't already deleted it or commented out, go ahead and do so. I'm going to do so to try to show you this versus this. Maybe you can see the similarities, right? For V in Word. For V in Word. ORDV. ORDV. So this just takes every value that's in the word, converts it by this function, and appends it to that list. So, kind of hard to read maybe the first time you see it, but it's a really, really convenient and powerful way. It's a lot easier to type one line of text than to get these 4 and hope you got them right. So, let's turn that eval2 back into a list of characters using list comprehension. So I'm going to call this word2 is equal to square braces CHR V plus 1 in parentheses. So we're going to turn the ASCII value back into a character for V in eval2. So for every character in our eval2 list, we're going to turn it back into an ASCII character based on its value, but we're adding 1 to it. And now if we print out word 2, we're going to see that it looks like that Python word, but it's going to have every character shifted by 1. And it did. We can see that instead of a P, we got a Q. Instead of a Y, we got a Z. Instead of a T, we got a U, and so on. We can kind of see that we'd run into trouble if this needed to go higher. If we were shifting by 2 rather than 1, a Y would become a Z. What's it supposed to do then? Typically what you do is you roll it back over to the smallest value you're supporting. Maybe this is going to become an uppercase A. So we'd have to subtract a certain value from it to get that to work. But that's the idea behind a Caesar cipher. And the reason we're spending a little bit of time on it is I want you to see the standard way of working with a list, which is using a for loop to iterate through the list. You do this over and over and over. I wanted you to see the way of creating a new list, which is to use .append. You create an empty list and then you start calling .append. And I wanted you to see the comparison between using list comprehension and this, because this code right here is the exact same as doing that code right there. You can see the for loop kind of embedded there. You can see the function call there, that ordv, and we're creating a new list based on that. Here is this author's code for doing a Caesar cipher. For every character in our plain text string, we get the ordinal value of it. We get a cipher value of it, which is the ordinal value plus whatever you're shifting. And then if it's too large, if it's gone past a z, they subtract a value from it to shift it back to the beginning, right? So if it's past z, you want to get it go back to a and start counting again. And then they turned it, back with the chr function into a letter that they could append to the string. This is the sentence that's giving me a little bit of pause. It's not how I would have written it, but I'm sure it works. It's just trying to shift it back so that if you go past a z, it goes to a lowercase a or something to that effect. I could just copy and paste this and see if it works. Let's find out. Whenever you copy and paste, the quotes wind up all being wrong. There's a very good possibility that I'm not going to be able to get this to work easily because of the quotes and other differences in how Microsoft Office encodes things. I guess it's useful for you to see that you may have to do this if you're copying code from somewhere. But if it doesn't work, then it was a waste of time. Let's give it a shot. Might work. No. No, I'm not going to mess with trying to figure out why. Why is that ORD there? Where did that come from? Oh.
So put a space in it.
Did I do that? No. Don't like that minus sign, do you?
I guess.
Probably treating it as a M space hyphen or something. Remember what the backslash means? It means just continue on the next line. Yeah, okay. All right, enter a one-word lowercase message. Hello there. Enter the distance value. I'm going to shift everything by -1. See if that works. All right, H became G. Space, interestingly enough, became a what? Or did it just leave out the spaces? H-E-L-L-O-T-H-E-E. Yeah, it just left out the space. I didn't see that in the code, though. What I'm doing here is I'm printing out the original letter, and I'm printing out the new version of the letter after it's had the code added to it, the cipher value added to it, and this will be the last I play with it. I just wanted to see what it was doing with the H. Well, I see it there, I see the space there, but I don't see it there. Can't explain it, not going to spend much time on it. That's crazy. It's adding it right there. Oh well. I'm going to delete this since I'm certainly not expecting y'all to have typed that. So, Caesar cipher. Take the numeric value of each letter and shift it up or down by a cipher value or by a distance value. Be sure to wrap around so that if the result is less than A or greater than Z, it won't be in the final product. I might not just do A and Z though. If I was going to go and look at the ASCII table, I would actually start my Caesar's ciphering at decimal character 32, right? Because we also want to include, you know, our numbers and our punctuation and stuff like that. So what could we do? If it is higher than a Z, we want to wrap it around to be an A. So if it was one more than a Z, if it's a 1, 2, 3, we want to get it to 32. Well, what's 1, 2, 3 minus 32? I can't do that in my head because I'm lame. 1, 2, 3 minus 32. So if it's greater than a Z, we might want to subtract a 91 from it. And if it's less than a space, we might want to add 91 to it. Right? Shift it the other way. So let's write our own version of the Caesar cipher because we're more awesome than they are. So, original string, or let's just call it text, they called it plain text, is equal to input, parentheses, quote, please enter a string to end cipher, in parentheses, in parentheses. Now we need a new string to start adding stuff to, right? We're going to start out with an empty string, but we're going to start adding stuff to it. So I'm going to call it new text. New text equals, and here's an empty string. Now we're going to write the simplest version of it first, which is just to copy things into new text unchanged to make sure it works. So, for every letter, I'm going to call it CH. I like CH. For CH in text, colon, now let's add that character to our new text. New text plus equals CH. Or I could get a syntax error. I put two parentheses where I only needed one. I got too used to needing to convert it to a float. But we're not converting it to a float this time. So, go back down here. If you did what I did and you put two parentheses there, remove one of them. Right there. Alright, now I didn't print the results out, but this is how you add every character in the string to a new string. That's a long way of doing it, right? Let's go ahead, though. Here's what we're going. Oopsie, where'd you go? Alright, let's get the ordinal value of that character. Ordinal value equals, how about we just call it oval again? Oval equals the ordinal value of that character. Now let's add or subtract something from it. What's our ordinal value going to be? Well, there's 25 characters in the alphabet. Why don't we shift everything like by 22? That'll make this text really scrambled looking. So oval plus equals 22, but we need to make sure it's not greater than a Z. What's the value of a Z? I'm going to go back and look at my ASCII table and find out that a Z equals a lowercase z. Oh, well, heck, let's even allow these symbols, right? Let's go all the way up to tilde. This looks weird, this delete key, so I don't want to allow it. So if it's greater than 126, I did 123 minus 32. Instead, I'm going to do 126 minus 32 to shift it all the way back. If it's greater than that, if it's greater than ASCII value, oh, come on. If it's greater than ASCII value for the tilde, which is just, you know, shift of the backwards hyphen next to the 1 key, then we want to subtract 26 from it, so to go all the way back to being a space, right? We got to wrap around, just like you're playing a video game and you orbit off one side of the screen, you got to come back on the other side of the screen so that you remain on the screen if you're playing one of those old-fashioned games like Asteroids or something. So let's check. If oval greater than 126, colon, and I'm going to put a comment, larger than tilde. That's the shift of the backslash, the shift of the key above the tab key. Then oval minus equals, what did I say the value to subtract was? I cannot remember. My memory is not looking. 94. Okay. Subtract 94. Take it to the bottom end of our range, which is a space. ASCII value 32. There's a way we can make this more generic because we have magic numbers here, right? 126 is a magic number, 94 is a magic number. They kind of go out of nowhere, come out of nowhere. We could define that as a variable. We could define that as a variable. Pardon me?
Are you sure you want to put plus equals ch for new text?
Not yet. We're going to have to change that. You're exactly right. Well, we could convert ch back to a letter now. So, untabbed, ch is equal to the chr of our oval. Now, calling it oval at this point, it's not the original value anymore, but it is the ordinal value, so I'm willing to live with that variable name. All right, and then I'm going to back tab all the way to the beginning, and I'm going to print the original text, and I'm going to print the new text, just so that we can see what they look like. And we should call this shift value, right? We have 3 magic numbers here that it would be a good idea to turn into variables. All right, please enter a string to Cipher. I love Python more than I love pizza. And there we go. That's pretty hard to read. Now, Caesar Cipher, like I said, is an incredibly, incredibly weak cipher. You would not, use this for like financial applications or whatever. But it's just something to, to prevent the display of something on something in the screen. That's one way you could do it. Check it out, though. If you were going to break this, what would you do? Well, one thing you could do is you could scroll through it and you could try to find which character is the most frequently used character. Because the most frequently used character in the English language is probably the space. And the second most is the E and the R. I don't have my frequency table memorized, but you could go through here and find which one of these characters occurs the most often, make it a space, whichever one occurs the less most often, and try it out as an E and then try it out as an R, and you could display those, and you might notice a pattern. Oh, well, it looks like if I just shifted this by 22, then all the spaces become this, and boom, it's done. Or you just look at it and you see if there's something that's appearing regularly, and you decide that that's probably a space, and you go from there. Right. Now, there are ways of making this cipher more difficult. Still not NSA banking financial grade difficult to crack, but a little bit more difficult. Can you think of a way of making this more difficult, to something that would not just be adding the same number to the ASCII value each time? What if we didn't add the same number each time? What could we do to make it way harder?
Maybe a random number?
Random number is a real good idea, but how would you decrypt it? Right? You would need to be subtracting random numbers, but that's the idea. That's the way a lot of encryption algorithms work, is that you have a random number that's generated by following a very specific sequence, right? You use a pseudo-random value. And we can even use Python to generate pseudo-random values if we set our starting seed. So that's how you do it. But instead of doing a random number, so that's harder, maybe we just add a 22 the first time, a 23, a 24, a 25, and a 26, and a 27, and a 28. And then it's not going to look nearly as easy to crack. We're not going to have all these sixes all lined up. So let's modify our code to do that. So instead of adding 22 to it, we need some kind of counter. And now's the point where I really wish that we had, called this like shift value or something like that. Let's get rid of that magic number and create a variable called shift value. I don't mind using a long word because we're only going to type it one place, is equal to 22. But we need to increase shift value every time we add one to it. So after that, I'm going to do shift value plus equals 1, right? So I just changed those two things, and I changed this one. So when you edit, if you are editing, you're going to want to change these 3 lines. Those are the lines that, nope, not that one. These are the 3 lines that changed in this last edit. So when I run it, I love Python more than I love pizza. Much better, right? The spaces are not all the same. Much harder to look at. Now the way encrypted text really works is the numbers that you shift them by or that you manipulate them by are encrypted using extremely long keys. 32-bit encryption, 64-bit encryption, or whatever, to manipulate the text in a way that it would be really, really, really hard for somebody to find the sequence by which each character was changed. Another thing you could do is what if you just use a repeating series, right? You could add a 22 the first time. You're going to use a 1 the second time. You're going to use a 10 the third time. And then you can add a 22 and a 1 and a 10 and a 22 and a 1 and a 10 over and over and over. Right, that would also make a difference. That's called a block cipher, I believe. They talk about block cipher next. Well, where could you get that series of numbers? Well, you could just take another word, right? Suppose I have this word. I want to encrypt everything by rows. Right. Well, the ASCII value of an R, a capital R, is an 82. And an ASCII value of an O, lowercase, I'm just going to make this uppercase, it's easier to spot. ASCII value of an O is a 79. The ASCII value of an S is an 83. And the ASCII value of an E is a 69. So you would just add those in sequence. First letter, you add an 82 to it, shift it by 82. Next one, 79. Next one, 83. Next one by 69. And you repeat that over and over and over. We could do that, but I don't want our code to look more complicated. It's already looking a little bit right. Now I chose this way of doing it even though it's got these magic numbers just because I thought that it would make it easier to understand. I hope it is. I hope we realize why we chose 126. If we wanted to limit what we were shifting, we could choose a smaller range, or we could convert everything to uppercase before, we started shifting, or we could decide that we're only going to shift the letters and not the punctuation. We could do that. That'd require a little bit more work. But how could we tell if something was a letter? Anybody know of a function that checks something to see if it's a letter or a number? But let's talk about letter first. What if I wanted to know if CH was a letter? I think I started to hear it.
Isalpha?
Yes, isalpha. Isalpha, right? So if ch dot is alpha, parentheses in parentheses, then let's just print. Found a letter. Right. I mean, this is silly, but We could do something more complicated if we find a letter, right? We could imply a different encryption, or I don't know what we could do. We could turn it to an uppercase letter, or I don't know. I just want to show you the existence of functions that examine strings to determine whether it's a letter, whether it's an alphabet, whether it's an alphanumeric, which means a letter or a digit. I think I just scrambled that when I said letter or alphabet. Whether it's a digit, whether it's an alpha character, whether it's alphanumeric, whether it's a space character, you have all of that function. All right, so I found some letters. I didn't even print out what the letters were. I just wanted you to see the fact that we could investigate. We could see that that's a letter. You can also check to see if it's uppercase. Is upper, is lower, stuff like that. I'm going to take that out, but we're going to play with that idea a little bit. I'm going to make a new string of text. Text equals I love Python so much it hurts. Okay, that's a little bit too long. How about that? I love Python, capital P. How about I love Python 3? We're even more awesome. We're specifying Python 3. Now the reason I'm futzing with it is I want lowercase letters, I want uppercase letters, I want punctuation, and I want spaces. So we're going to write another loop that's going to step through this. One of your homework assignments, tasks, was to step through a sentence and print out all the letters. We can do that. For ch in text, and there's nothing magical about that variable name, it just makes sense to me, a character or ch. I could probably even use the whole word in this language, but in other languages, that's a key word that's reserved. So for ch in text, colon, let's print out the letter. Print out ch, comma, but I really want to keep adding to the sentence, right? I don't want it to go to the next line. I don't want to hit enter on the typewriter keyboard. So I'm going to use the end parameter to specify. Don't go to the next line, just put a space there, because we're going to start adding things to it. We're going to print whether it's an uppercase letter, or whether it's a lowercase letter, or whether it's a digit. So we're going to have several if statements. If ch.isAlpha, parentheses in parentheses, colon, print letter, end quote, comma, end equals, quote, space, quote, in parentheses. You know, guys, I'm going to try something. Don't do this. It's just curiosity on my point. Seems to work. Why am I interested in doing that? Because then I could take this, copy and paste it, and change it to like if is digit. Print out digit, right? Just curious. Yeah, so that is working. That syntax is working. I'm kind of impressed. But we're not going to do that. Okay. But we can just copy and paste this rather than type it over and over. It would help us a little bit. Might help us with speed, but maybe you don't like copying and pasting. I don't know. But let's use is digit to see if it's a number, and then use is upper to see if it's uppercase, is lower to see if it's lowercase. I'm going to copy that. I don't know if that's going to mess y'all up or not. At least copy that's prints. Yeah, we'll just type the whole thing. We'll rough it. If ch dot is upper, parentheses in parentheses, colon, print, parentheses, quote, upper, in parentheses, comma, end equals, quote, space, quote, in parentheses. Really, we should copy and paste. Copy that and change the uppers to lower. Now let's run it. Oh, and at the end of our loop, we just need to print a carriage return. We need to go to the next line. right? Because we keep appending things to our text, just like on a typewriter. But we've got to go to the next line. So here, the last thing in our loop is just going to be a print statement. Not even anything in it. Just a print statement to get us to go to the next line, print out a new line. And boom, I messed it up. I don't have it lined up exactly. It looks like it's lined up, but I put it one space too far. And now it's getting to the bottom of the screen where I can't see anything. But anyways, we see it. I is a letter and it's uppercase. L is a letter and it's lowercase. O is a letter and it's lowercase. Capital P is a letter and it's uppercase. These spaces aren't anything. This 3 isn't anything, and this I isn't anything. So what else do we want to know? We want to see if it's a space, and we want to see if it's a digit. Well, we've got checks for that too. I'm just going to list what I want you to check for, and I want you to modify your code if you so choose. Use is digit to print out number, right? Use is space to print out space. Now space looks like it'd be really easy, right? Like you could just check it equal to a space, you know, if something equals. Sorry guys. Be quiet. You could just use if character equals, you know, quote, space, quote. But there's more kinds of spaces than just that. There are tab keys. There are new lines, /n's. There's, you know. So, is space checks for all of those. It's called white space, really. So go ahead. Do those. Add those to if statements. If ch is digit, and then if ch is space. Print out that it's a number. Print out that it's a space. Okay. I want to see somebody's got it done. So.
No.
All the way. I think it's okay for the TV code, but yeah, these can be tabbed over one. So they don't too far back. So everything after the for statement, down to the print, but not including this can be tabbed over, not before. Stuff inside the door. Yeah, everything. Because it's all part of the folder. think some of y'all got it? I can do another walkabout. Yes, sir.
That's probably okay. Show me your code. I'd have to run it again here, but it's okay. This is the basic idea with shifting. We see that it is shifting at which direction. Let's change shift value to 1. That'd be easier to spot. Or even shift value equals 0. Yeah. And run it. Alright, so H became a day. Oh, not it's also cost 22. Looks like it costs +1. I should have. It's. That was taken as zero. So H becomes I, right, and so on. So run. Y'all doing okay? Okay.
Yeah, how do we check for the exclamation mark? Basically, you use not, right? Because if it's not a letter and it's not a number, well, we have one more called isalpha. We could do that. So if ch dot is alpha num, I think that's correct, colon and colon, print alpha numeric, end quote, comma, end equals, quote, space, quote, in parentheses. But let's throw in an else. Because if it's not alphanumeric and it's not a space, then we know it's a punctuation. We know it's a special character. So, one more if. Forget the idea of the else. I did realize that else isn't going to be sufficient to our means. If ch, or if not, ch dot is space, parentheses, in parentheses, and not ch dot is alpha num, parentheses, in parentheses, colon, print parentheses, quote, punctuation. End quote, comma, end equals, quote, space, quote. Like that. Now, I didn't do these two. Like y'all did. Some of y'all. It's all right. Boom. It's not called is alpha num. Does anybody know what it really is? You were just looking it up. What is it really?
It's is al num.
It's al num, not alpha num. So change this alpha is alpha num to just al num. Take out the PHA. So I just had to change that. I'm going to have to change it in a couple more places. Here. Right? Got to change it there as well. All right, it's not calling out the spaces, but I didn't write those if statements. It did catch that the exclamation mark is a punctuation. This code right here could be turned into one of those password evaluation functions. Right? Password must have one special character, one number, and one uppercase letter, right? So we could use is upper to see if there's an uppercase letter. We could use is alnum to make sure that it's got, a number in it. And we could use if not ch is space and not ch is alnum to see if it's got a special character, in other words, a punctuation. And typically people don't allow passwords with spaces in it, which is kind of dumb because then you could make an entire sentence your password and it'd be much more difficult to crack. You know, I love pizza would be more difficult to crack than just, you know, password as your password, especially if you threw an uppercase and lowercase and stuff like that. So I'm going to add some comments. And by the way, is alphanumeric and is space and is upper and all that works on lists of characters, not just a single character. If you have a string, like if you have an entire word and you want to make sure that it's all letters, you just call isalpha on it. Doesn't matter whether it's one letter it's checking or, you know, 1,000. It would return true if everything in it is an alpha character. So you can use functions to determine if something is a letter, digit, uppercase, lowercase, or space, or punctuation if you use not keywords, just like we did here. And what are the functions we tested out? We tested out is alpha, we tested out is upper, is lower, is alnum. It's funny how they use the term number in one place and digit is another. Is digit and is space. Those are the ones that we have mentioned. I didn't take the time to implement is space and is digit, but I could have just copied and pasted. Let's add a few more comments. Since I'm adding more comments, I'm just going to open up a triple string. Use this general format to step through a string character by character. For CH in S, S being a string, do something with CH. Print it out, take a letter, add it to something, whatever. To step through every item, every element, that's a fancy word for it, in a list. For EL in L, I'm using capital L for list because lowercase l's are very hard to see. They look like ones. For EL in L, do something with EL. Use dot split to turn a sentence or other string data into a list. And let's give another example of that. This is part of our homework assignment. Whoopsie. Where'd that A come from? Go back up. So let's make some data, which is just numbers. 405-821-282, you know, don't dial that. I don't know whose phone number that is. Right, that's a first, a second, and a third, right? It's to the area code and the prefix and the digits. Oh. List equals data.split parentheses. Now, if we didn't put a parameter in here, we'd just try to split by spaces, but that's not good enough. We need to split by the hyphen. So split parentheses, quote, hyphen, in quote, in parentheses. Now we have 3 pieces of data we could play with. Print that list just to see what it looks like. And we could say area code equals list subscript 0. It's the first item of the list, right? And the prefix is the second item of the list, list subscript 1. Probably typing a little bit too fast. I need to slow down. And the number, or the last 4, equals list subscript 2. Of course, this would kind of break down if there was an extension or something, but for simple parsing, it'd be okay. Now, sometimes people separate these things with periods, or they don't put any spaces at all, or they use parentheses or whatever. We'd have to write much more complicated handling function. And then we could print that stuff out. Print parentheses, quote, area code equals, end quote, comma, area. And we could print out the rest too, but that kind of proves the point. I'm going to scroll back up so that if you didn't get the earlier statements. Ooh, unexpected indent. For somehow I wound up with a print statement a million miles below everything. Hopefully you didn't. And there I accidentally closed the window. Brilliant. Let's get that back up. Scroll way down here. Find that print statement. I know where it was supposed to go. Woohoo! It was supposed to go at the end of our for loop way up here. You don't have to add this if you didn't goof like I did. Alright. Alright, and so it took our phone number and it picked out the area code from it by using dot split. Dot split is very useful. It gets a little bit more interesting if you're trying to split based on several different things. Like, I want to split based on both whether it's got spaces and hyphens. I don't even know how to do that. Let's Python.split multiple delimiters. Delimiter is a fancy word for the space or the hyphen or the comma that separates each piece of word. Oh, neat. You do something called regular expressions. You import RE and you use RE.split, and you can specify a whole bunch of different characters that you want to split based on. Yeah, so it's possible. Yeah, not going to cover it. I mean, make us type it in today. But those are delimiters. The delimiters are the characters that separate. You can export data into what's known as a comma delimited file, and then you can import it into Excel. And then you can manipulate it in Excel, right? You could use it as a spreadsheet or whatever. That's a very common thing to do. We'll demonstrate that when we're writing the files. That's probably about enough. I think we got past one slide. But let's look. Here's the decryption code. The decryption code is just the opposite of it. You use a negative shift value rather than a positive shift value. If we took our string and we shifted everything by negative 22, but then we added that thing where we added 23 and 24 and 25, we'd have to be subtracting 1 from it, right, to get it to work. But anyways, we could do that real easily just by cutting and pasting some code and making 2 changes. And a block cipher. That is where you encrypt based on not just a value of 22, but you create a list of values to shift by based on another word, right? Or another series of values. And ooh, uses an invertible matrix. That sounds weird. Yeah, I'm not going to talk about that. All right, and then we get into a completely different topic that I know we've brushed upon. The idea of base 10, binary, and hexadecimal, and octal. We're going to save that for a later day. So we got up to slide 17, so to speak, because we talked about some of these things last time. All right, so homework based on this concept. Not going to be terribly long. Ask the user to enter a series of numbers separated by commas. convert that to a list using dot split, and then print the list with a for loop. Ask the user to enter a series of words separated by colons. Convert to a list, print the list with a for loop. Ask the user to enter a word and print out the ordinal value, the ASCII value of each character in the word. And then lastly, ask the user to enter a word, print all caps if dot upper is true, else print not all caps. In this case, you're not going to have to parse it letter by letter. You just use word dot upper or whatever. You know, word equals input, something like that, right? And then print all caps if word dot upper is true. Just trying to show you that you don't have to do it letter by letter. You can use an entire word. Alrighty. I think all of this is quite doable with the code examples we typed in today. We know how to separate things by commas using dot split. We know how to separate things based on colons. We know how to step through something letter by letter. We know how to get the ordinal value. You don't have to do anything more complicated than that. You don't have to add, you don't have to shift, you don't have to convert back to an ASCII character. Ask the user to enter a word, print all caps if it's true, else print not all caps. Yeah, I think that's a reasonable homework assignment. Make sense? Cool deal. Did anybody not take the exam? I would need to open it up at the library for you. It looks like everybody took it. All right. Had a bunch of people, not in scripting, but in fundamentals, just not show up on exam day. And it was actually my fault, which made me embarrassed. All right. So anyways, let's make a Dropbox for this. We can stay after for a little bit if you need help with homework, but I'm not going to be able to stay very long, unfortunately. But then I can meet you in my office afterwards.